Hi, good evening, everybody. So we're now live streaming, and we're also being recorded. My name is Isabel Germano. I am the chair of the AANS CNS Joint Section on Tumors, and we are extremely happy to be in the same room together tonight. The mission of our organization is to promote activities that allow the physicians, the patients, and the public to become more familiar with the tumors of the central nervous system, brain and spine. And I think one component that we all want to enhance is to get to know each other and to get each other more comfortable in interacting with one another so that we can continue to improve the care to give our patients. That said, I am very pleased to introduce to you Brian Nahed, who's the chair of tonight's event, and Susan Panullo, who's the co-chair. There are also executive committee members and chair and co-chair of the promotion committee. So thank you very much for chairing this event tonight. Brian and Susan, you have the floor.
Thanks so much, Isabel. And I'm really looking forward to doing this program with you guys. We had actually found in our brain tumor conferences during COVID, when people started getting a little bit cranky and disconnected, that bringing a personal element into the conversations helped to facilitate conversations, improve patient care, and actually made everybody less cranky. So not like this is a crabby crowd. I know everybody's happy and fun, and I think that we'll continue this during the conversations this evening. But I thought it was a brilliant idea. Hopped on the train immediately, have been having a really good time with Isabel and Brian pulling this together. So I'll hand it over to Brian.
Well, thanks so much, Susan. I just wanted to echo your thoughts. I think we are so fortunate to be such a small community of brain tumor surgeons in the US and internationally, and to link all of us together and also learn about one another, not just the academic stuff which we see at the annual meeting, but hopefully something a little bit more. And we hope we leave everybody today with a better understanding of not only the stuff that is amazing stuff that's happening, but frankly, the link of all of us to one another. And hopefully you'll learn something new and exciting about each one of the panelists tonight. With that, I'm going to try to keep us on schedule. We are 1 minute ahead. Thank you again to Susan and Isabel for putting this together. It's been really, really exciting. We're going to start with, I believe, Alfredo, who will do the first introduction. And for all our participants today, you'll hopefully see a different and new format. And we can't wait to see how this goes. So Alfredo, I'll turn it over to you.
Thank you, Brian, Isabel, and Susan. Thank you. I want to introduce Mike. So also formerly known as Michael Lim. He is a professor and chair of neurosurgery at Stanford. He is also in the AANS CNS section on tumor executive committee role. He is in charge of the education committee in the scientific program committee of the CNS of 2022. So if you want to get your papers accepted for talks, this is the moment to start making sure that we're nice to hear. All right, so he does amazing work in the laboratory. I had the privilege of learning from him when we were both together at Hopkins for actually a decade, and we had an amazing time, and I just really enjoyed learning CNS from him. 2022. So if you want to get your papers accepted for talks, this is the moment to start making sure that we're nice to hear. All right, so he does amazing work in the laboratory. I had the privilege of learning from him when we were both together at Hopkins for actually a decade, and we had an amazing time, and I just really enjoyed learning from him. And I'm not quite sure what happened there, but I'm hearing myself talk. So
Alfredo, it was so good. We wanted to hear it again.
I know, seriously. Thank you. So I leave it at that. He does amazing work in immunotherapy for brain tumors, and I am just so inspired by the work that he's done through the years. And I'm looking forward to the true and false portion of this.
Wonderful. Isabel's getting the screen share back up for Michael's slides.
Yeah. So this was so good that discombobulated the entire computer, but I think that speaks for a great introduction. And here we go again.
And Isabella, did you wanted to show the slides about the research or anything else, or How are we going to keep it? Or is Mike now going to introduce me?
What is happening right now is that for some reason my computer decided it was too
Wait,
late in the
You got
day.
it?
But here we go again.
You got it. You got it. You got it.
Okay,
Yes.
wonderful. Well, thank you. Thank you, Dr. Quinones, for that really wonderful introduction. I get to introduce you in a second, and thank you to the organizers, Dr. Panullo and Dr. Nahed and Dr. Germano for this opportunity. So I guess to kick it off, I think we're all tasked to kind of talk a little bit about something that we're really proud of. So, or that has been a big part of our life. So for me, I chose to talk a little bit about the research and how I had this incredible opportunity to go back and forth from the lab. And so I used the slide and started off with, actually, before this, I had actually seen one of the first patients ever treated with anti-PD-1 in my clinic. And at that time, I didn't know what that drug was, but I saw patients getting an amazing response. So I took that finding from the clinics and took it to the lab. And through the work of my postdoc, Jing Zhang, we actually saw that anti-PD-1 improved survival. Do you mind hitting next, Dr.? And so that was 10 years ago, and fast forward 10 years, and we just published our 2 phase 3 results. Each trial was about 600 patients. And getting to this point it took a long time, but unfortunately the trial results came back negative, but I learned an incredible amount just to be able to figure out going from animals to phase 3 data. But next slide, please. And next, but one of the things that we get to do as scientists and as surgeons and clinicians is that we get to shuttle back and forth. And so we had an idea a little earlier that this wasn't working. And so we were able to go back to the lab, and next slide, please. We were able to find other targets. And so in this situation, in this case, for example, we saw anti-LAG3 was upregulated in cancers, and we went back to the animals, tested the combination of anti-LAG3 and anti-PD-1. And then next slide, we then went back to the clinics again and ran a large multi-center phase 1 trial where we saw actually, next slide, please, some really interesting results. We actually saw some patients responding to this therapy, and now we're actually going back to the alliance. And what was really neat about this one is LAG3 is something called relatlimab, and I don't know if you just saw, but it was approved by the FDA for the treatment of melanomas. Is the next new immunotherapy agent. So to me, this was really exciting, not only because we got to follow the science, but it was also because I got to work with an amazing group of people, oncologists, neuro-oncologists, radiation oncologists, neuropathologists, neuroradiologists, biostatisticians, and got to work with people in different institutions. And to me, it's been an incredible journey. And really, I felt closer to a lot more people in our field and got to know a lot of people in our field and hopefully make a difference for people. So I guess we can go to the next slide, please. So yeah, we're all asked to put a little personal part about ourselves. So this is my family. On the left are my parents. They moved from Korea a couple years before I was born. And my parents instilled in me the values of hard work, determination, and being able to adapt. My dad and mom came to this country speaking no English. My dad memorized a big part of the dictionary, or most of the dictionary, to be able to pass the entrance exams, and then became an engineer, and then got laid off when he was in his 50s, and pivoted, and he and my mom opened up a convenience store just so that my sister and I could have this opportunity in this country. And then on the right is my family. My wife, Mary Shu, she's a dermatologist. I met her in residency. She's the love of my life, my best friend. And with her, we have 2 girls, Olivia and Violet. Olivia is 12 years old now and really loves to figure skate and tennis. And Violet, she is 9 and she loves Minecraft. We're trying to get her into sports, but she loves Minecraft. So I guess for the next part, how do we do the true and false? Should I
I'm gonna try to guess it, Mike.
Yeah,
All
I'm
right.
ready.
he's
I'm
gonna try
ready.
to guess.
I have a
So
poll
it-
too. We can also launch a poll. So maybe you can read number 1, 2, and 3, and then we'll do the poll, and then Alfredo will
Yes.
try.
Okay. So first, true and false. I love McDonald's so much that I worked there. Second, my career as a cancer biologist started with studying leukemic clams. And then the last one, I always knew that I wanted to be a neurosurgeon.
Okay, the audience can vote now, and Alfredo will think for 3 or 4 seconds. People are voting as we speak. I mean, as we don't speak.
Yeah.
All right, Alfredo, go for it. I'll tell
All
you
right,
what the
very
public
simple. All of them are true.
Okay.
He's got an extraordinarily strong work ethic that he learned from his parents. He's been a scientist since he was born. And he, judging by the way he practices neurosurgery, this young man was always destined for greatness. That's what I say.
All right,
Well-
the public said that the true is that you always knew you wanted to be a neurosurgeon. 42% voted number 3.
Okay. Well, the first 2 answers are true. I love Big Macs. So I worked at McDonald's getting paid $3.75 an hour. And I spent most of the money buying the food back. And then I went to the University of New Hampshire, which is a big marine biology school. So I did study leukemia clams from Boston Harbor. So don't eat food coming out of Boston Harbor, by the way. And then actually, I started my career thinking I wanted to be a pediatric hematologist, oncologist, and then actually molded my life to be an oncologist, and then switched into neurosurgery last minute. So after I did my surgery rotation.
So I did better than a major league baseball player. I was 6%, so it's good.
That's great. All right, my turn, right? I get to introduce Dr.
Yes.
Quinones.
Yep, go for it.
So as Dr. Quinones mentioned, he and I have been lifelong friends. I've known him actually even during residency when he was a resident up at UCSF. Sometimes we shared patients, and then I got to work with him at Hopkins. And then he was recruited away to the Mayo Clinic to become the William J. and Charles H. Mayo Professor and Monica Flynn Jacoby Endowed Chair of Neurologic Surgery at the Mayo Clinic. He also serves on the executive committee in the AANS CNS section on tumors. And he is in the committee of development and partnership. And Dr. Quinones is a force of nature. Having worked with him the first day, I showed up with this big smile on his face when I was at Hopkins, and he's done a tremendous amount of stuff, and he'll share that right now.
Thank you, Mike. Well, I am excited. Thank you for the beautiful introduction. After this, everything is going to go downhill. I also, just like Mike, I had a passion that dates back to our residency time. We shared patients with brain tumors back then when we were co-residents. I was at UCSF and he was at Stanford. And I would always been fascinated by this go and grow in brain cancer. So just like Mike, we figured out the way to use the operating room, what we do in the operating room as an extension of the laboratory. And you can see, obviously, with collection of tissue, creating a biobank, we have been able to find some of the molecular engines that allow cells to migrate and invade. And for the first, it took me, since 2015. So those are some of the cells migrating, invading. I mean, they're very aggressive. And over the last, by accident in 2008, when I was there with Mike at Hopkins, we found that actually stem cells from fat can actually be used as Trojan horses. So it took another decade and a half before we opened our first human clinical trial with stem cells from fat engineered to carry a protein. So that's we're about to open that. So I'm much slower than Mike. He already been opening clinical trials for some years. I'm just barely getting going, but hopefully we'll get it going pretty soon. So that's what I can say. Should we go to the true and false?
Yeah.
Let's do it. Let's see the next one.
Isabel, will you move us to true false?
Well, yeah. So there's a picture.
Aren't you supposed to talk a little bit about yourself?
Yeah.
About me? Yes, that's perfect. Before I say anything about me, that's the picture, of Rocky and Apollo, which, by the way, they are the center. We have 2 cats and 2 dogs. And in our family, they're like the center of the family. Incidentally, when I come home, they're still the only ones who pay attention to me. Everybody else, yeah, whatever, Dad. All my kids are, yeah, whatever. So they are, but Rocky and Apollo, man, every time they see me, oh my gosh, I love you, Daddy, I love you. Last night I posted something in Twitter. I told my wife, look, 7:30, he's gonna come and get me for a walk. They think that I take them for a walk, they take me for a walk. 7:27, he was there. That Rocky is the one with white with brown spots, and Apollo is the brown one. As you can tell, I love the Rocky movies, all of them, all like 100 of them. I watched them all many, many times. And I am just delighted to be here with all of you guys. And I am married. My wife, Anna, has been amazing, very patient with me. We have 3 kids, ages 23, 20, and 16. So soon we'll be empty nesters. There you go.
All right, so the true and false. So I think the first one was already answered for us. Your favorite movie is Rocky.
Crap, why did I do that?
You want to read the other 2 for us to do the
Yes.
true and false?
So do you think what is, I used to be an amateur boxer, yes or no? And can I bench 225 pounds 5 times?
All right.
We're going to open it for the poll. Let's see.
Yep, this is open for the poll. Let's see what people say.
So having known you, that I get to cheat a little bit. I do know that I've known you for a long time. I know number 2 to be true. So I thought you can only bench 224 pounds 5 times. So I'm guessing 3 is false.
You're absolutely right. The first 2 are right. The last one is definitely false. I can probably barely bench like 100 pounds. That's the truth. I am more like a resilience rather than strength,
Alfredo, 36% of the audience got it right. So smart people.
Thank you, Samuel. Wonderful, Mike. Thank you.
All right.
All right. I think I'm up next, and I think I have the privilege of introducing Dr. Kimberly Hung. So I feel kind of sheepish. I've known Mike Lim for certainly well over a decade, somewhere between 10 and 15 years. I've known Alfredo for over 20 years. I don't know that I've ever met Dr. Hung before, so I'm going to read what I've got, but we're all going to learn today. So that's the purpose of this event, is to allow people to learn more. So Dr. Kimberly Hung is an assistant professor of neurosurgery at the Emory School of Medicine and the Winship Cancer Center in Atlanta. She has, as we all do, roles in the tumor section executive, where she is the communication committee chair. So I'm going to turn it over to her, and I look forward to hearing more.
Great, thank you. Sorry, I think my slides got a little messed up there, Isabel. Maybe I can share my screen, or it just got my graphic got a little funny right there. Okay, let me share mine and let's see if that works. So actually, Dr. Parney, I met you a long time ago when I was a sub-I at Mayo, so quite a bit.
See, so I have all these other problems, including a really bad memory. So
don't worry about it. Can you guys see my screen now? It looks a little better.
It says your screen sharing. Oh, there it is. Now you got it. Yep. You're up.
Perfect. All right. Well, sorry for the technological difficulty. So I'm going to talk about my research project that my group, along with my collaborators at Georgia Tech here in Atlanta, we're very happy that we just got this accepted for a conference paper in a pretty big conference for us for small scale robotics. So the impetus for this is that I used to be an engineer. I've always tried to sort of pursue projects where I thought robotics might be helpful, particularly for tumor surgery and cranial neurosurgery. And I honestly think that the current robotics are great, but could be paradigm shifting. And so one of the projects that we're working on is actually taking a look at these things called microrobots or microrobotics, which are somewhere between tiny nanoparticles, right, and larger robots that we know in the operating room. And you probably may have seen them. My partners call this like my sci-fi stuff, but you may have seen them. They can either work individually or swarms, and they're previously had been used or are very popular outside of medicine, but are now starting to be applied in medicine and really have not been applied to neurosurgery. And so we've been working on this for the past couple of years. to basically create what we show here, which are these magnetically actuated. So there is a Helmholtz coil, or basically a magnetic coil system that goes around the head, and they are untethered, which means that there's no onboard power or actuation. They're just all controlled and moved via this coil system. And we are trying to use them for potentially cranial neurosurgery applications, including things like targeted drug delivery. So this is an example of that, where we demonstrate that we can add a hydrogel backpack full of nanoparticle drug. And you can see that in the first picture, where you can see the fluorescence is a sort of proof of concept for that release of the a nanoparticle or the drug over a difference in pH between pH 6.2 versus 7.8, which is the difference between potentially tumor and normal tissue. And this is an example of this very small micro robot that we have then that can drill through brain tissue in controlled nonlinear trajectories from the surface all the way deep throughout the brain. Right now, we're doing them in cadaveric pig and sheep brain. And these are just some of our early results that shows we can do these very nonlinear trajectories here. We're at the bottom of the screen, you can see where being able to spell out the word, this GT, which is Georgia Tech, my collaborator works on. And so we can do these very complex shapes throughout the brain. And so we have microbots that can swim, that can move on the surface of the brain, and can drill through the tissue, which is actually quite difficult at these small scales. So that's all that I should say about that. We can go on to the personal aspect of things. I'm going to stop share, Isabel, so you can go back to the personal slides if you'd like. Okay. So I don't want to say too much and give away the answers, although it's not super exciting. I don't know. But this is a picture of me on a travel last year, just recently. And this is in Maine. Some of you guys have probably been there to Acadia. But my true and false questions are as follows. And of course, one typo, so I'll tell you that. So the first one is I'm currently poorly planning a wedding in Greece. The second is they should say I do not have a crippling acrophobia or fear of heights. And the third one is my parents tried to send me to West Point Military Academy when I was a teenager because they thought I was rebellious, which, yeah. So you can go ahead and pull.
All right,
Thank you.
No, go for it.
I don't know, but I'm going to say that the false, well, we'll let everybody do their polls and then I'll weigh in.
All right, and you have another minute. People are voting as we speak, and then you're good to go now. Mm-hmm.
All right. So my guess, and it's truly a guess, is that it's actually number 3, that your parents tried to send you to West Point Military Academy as a teenager because they thought you were rebellious. Because in fact, you have to have graduated from high school. West Point's a college, so I don't think that makes sense.
Oh, they tried. They certainly tried. I'll get there. So I am planning a wedding in Greece. And I actually, even though I put this picture up there, it's kind of fools you, I guess. But I have really actually terrible acrophobia. The only way I can get to the top of any trail, which my friends always force me to go on, my partner is, lots of swearing, and I have to, it's really stressful. So I got to that with a lot of swearing to the top. And then actually my parents sent a recruiter to my high school, and I went to an all-girls high school to try to get me to go to West Point Academy because they thought I was rebellious. I am the most rule-following person, so I definitely was not rebellious.
Kim, you fooled the audience. Nobody got this one.
Good job.
Okay.
Right. So Kim, you're doing Ian. Yep.
Yes. All right. So let me get my thing correct. So Dr. Parney is, as we mentioned, from the Mayo Clinic. He is a professor and vice chair of research for the Department of Neurosurgery at Mayo. And for the tumor section, or the tumor executive committee role, he is the history committee chair. So Dr. Parney, I really enjoyed your slides about the promise and peril of immunotherapy, and particularly interested to hear about your liquid biopsy for GBM.
Sure. So I'm just going to kind of give a 40,000 1,000-foot view of some of the things that I've been privileged to work on for a number of years now on immunotherapy. Like Mike Lim and others, we're very interested in trying to apply immunotherapy to glioblastomas. And so I've been involved in a number of different clinical trials of different vaccine platforms and immunotherapies with checkpoint inhibitors and viral immunotherapies. And we've had a modicum of success in small trials and small populations, but never anything sort of that's really hit it out of the park, because I think everybody who works on immunotherapy would tell you. There's a lot of potential reasons for that. One of the things that's become a focus in my lab is the fact that sometimes you get things after treatment that look like tumor that are tumor, which suggests that your immunotherapy just didn't work. And sometimes you get things that after treatment with an immunotherapy that are just an inflammatory pseudo response. You kind of look in the right upper quadrant there. We've been kind of interested in dissecting down on that. So part of that, I've gotten this interest in extracellular vesicles, these little bits of cell that get shed by every cell in the body. And they're really good mediators of intracellular communication. And so we've been working on the lab for a long time and understanding how brain tumors inhibit the immune system, particularly affect monocytes and make immunosuppressive monocytes. And it turns out that these glioblastoma extracellular vesicles are really important mediators of that immunosuppression. And then I just have a little bit of kind of colorful Tisney plot data from some flow cytometry of plasma extracellular vesicles in glioblastoma patients. We're very interested in developing a liquid biopsy that can tell us maybe some idea of what is tumor and what isn't when we see this at recurrence on imaging. And it turns out that extracellular vesicles are present in the plasma, and you can find tumor-derived EVs in the plasma of GBM patients, but they're pretty rare. But what we are beginning to see, and this is work of Zach Abidallah, as a PhD student in my lab, is that even just by flow cytometry, looking at a bunch of non-neoplastic markers for EVs in the blood, you can see pretty dramatic differences between brain tumor patients, glioblastoma patients, and normal healthy donors. So that's kind of a spectrum of some of the stuff that we're working on to work on some of these liquid biopsies and see if we can have something that will help us understand who should come off our experimental immunotherapy and who should continue, because it's either true progression or pseudo progression. We can kind of go on and do some of the personal stuff maybe here. So a little bit about me. I like to run marathons, and we can just click through some of the pictures there. That's me at Boston in 1990. That's the Grandma's Marathon at Duluth along the north coast of Lake Superior. We can go to the next one. That's me after running the Goofy Challenge, which is a half marathon on one day and a full marathon on the next day at Disney World. Go to the next one. That's me with my older son and younger son. My wife and I are blessed with 3 sons. Our eldest has just graduated from college and commissioned as a second lieutenant. My youngest is just going into high school. Our middle son sadly passed away a couple of years ago. But sort of to share with family and do the things that I enjoy and we enjoy together has been a real privilege. If we just go to the next one. And that's me with actually Desmond Brown, who is on this call. I believe Desmond is one of our former residents and fellows who is now on faculty at NIH as the director of neurosurgical oncology there. Desmond wanted to run a marathon, and this is him holding me up at the end of the marathon that we ran together. So we can just go on to the true or false. So there's the 3. You can decide. So 2 true, 1 false. Senator Ted Cruz and I were born in the same hospital in Western Canada. I have worked as a carny, and I have performed professionally as a singer, trombone player, and pianist.
All right, think about it for another minute. People are still voting.
I'm really hoping that you have worked as a carny. I think that'd be very interesting. Okay.
The audience is split. The audience is split 50-50. One choice is 0, and the other 2 are 50-50. So you have to break the tie.
That's fine. I think number 3 is false.
You are correct. I have performed as a singer, trombone player, and pianist. I've even been paid to play trombone and offered money as a singer, although I really shouldn't have. Nobody in the modern world is ever likely to pay me to play piano. They might pay me to stop. But Ted Cruz and I were both born in the Foothills Hospital in Calgary, and within the same year. Actually. So maybe we were switched at birth. I don't know what that means, but and then I have in fact worked as a carny. You get a ring on a bottle, you get any prize that you want. The biggest prize is on the Midway. So that was my first job out of high school in the summer. I worked as a carny on a traveling Midway show in Western Canada. So that's a little about me.
Okay. So Brian, next we have Wally introducing Annalise, right?
Yes. I have the privilege of introducing probably one of my favorite Twitter neurosurgeons. I'm a big follower of hers. Annalise Rodriguez is the assistant professor and director of neurosurgical oncology at the University of Arkansas for medical sciences. And currently she's serving as the education committee co-chair and is going to be the CNS scientific program chair in 2022. So that's really exciting. I'm looking forward to that in San Francisco. And I just have very much enjoyed watching her career progress, and I'm a big fan of hers. So I think she's going to give a little intro into her research.
Well, thank you so much for that introduction. So I am one of the worst people at doing PowerPoint presentations, but I took these figures from a recent paper in my lab. And basically what I'm interested in is precision medicine, specifically using patient-derived tissue for modeling with organoids. And then instead of, a lot of people, when I think of precision medicine, what comes to mind is having an actionable mutation and then giving a person a drug. But unfortunately, not everyone has an actionable mutation, and a lot of times that may not even work. So I'm more interested in functional precision medicine, which is testing directly on tissue, as well as using omics to actually predict maybe what some targets are. And especially for people who don't have DNA mutations, maybe using RNA transcriptomics to look at pathway analysis and identify targets in that way. So this is from a recent paper, a patient of mine on the left. This patient had a Li-Fraumeni syndrome, which is a cancer predisposition syndrome, and they underwent a lot of surgeries. Obviously, at our institution, we do operate on a recurrent GBM. You can see the myriad of treatments that they've gotten. And thankfully, we were able to biobank these tissues and do advanced analyses. And then to the right is just a workflow that we developed in regards to using the tumor tissue to identify targets with RNA, and then actually making organoids and testing some of our targets. And this patient was the first patient that we used a protocol on for one of his recurrences, and that was the one that he had the longest progression-free survival. So now it's something we're thinking about doing for other patients. I guess we'll go to the next slide. So I tell people that the beach is my natural habitat. I grew up in Southwest Florida, the Gulf Coast. So this is actually one of my favorite beaches, which is off of Longboat Key, if anyone has been on that island off the coast of Sarasota. And so 3 things about me: I learned to snorkel off the Florida Gulf Coast. I took karate as a kid, and I missed Game 7 of the 2016 NBA Finals.
All right, Wally, think about it for a minute.
While they're answering the questions, I'll put my thinking cap on. I'm deciding between 2 and 3 here. I'm gonna guess you missed Game 7 of the 2016 NBA Finals. Incredible series, but I'm sure there was a good reason for it.
You know, I'm wondering if, yeah, maybe I did these the wrong way. I only have one thing that is false, but you're right that that one is a truth. So I did unfortunately miss Game 7 of the 2016 NBA Finals, probably one of the best games of NBA history, because I was driving to my fellowship, and I'll never forget getting a text message while filling up gas outside of Nashville that I missed one of the best games of all time, and the Cavs won. And if you know me, you know I'm a big NBA Finals fan, so it was like devastating. But yes, you're correct. That one is true. So then another one is false.
I guess it's taking karate as a kid. I guessed wrong there.
Okay. So actually the first one is the wrong one. I did that on purpose. So I did take karate as a kid, and it's just that I actually do not know how to snorkel, which is kind of crazy considering I grew up on the Florida Gulf Coast.
So Annalise, you fooled the audience as well. And knowing you, I would have picked number one just because you put that picture of the beach. I know that you're very tricky.
I know. I was trying to do that on purpose. I was figuring that most people would be like, well, if you grew up there, then you have to. So I did that on purpose.
It worked. Yeah.
And I'm trying to pull up the slides so I can properly introduce. Okay, perfect. All right, so I am going to be introducing Will. Do you go by?
Everybody calls me Wally. You can say
Wally. Okay, yeah. I thought so. I was like, I don't think I'm not sure if I did.
Getting to know each other.
Yes. Okay. So I'm going to introduce Wally. So he is the director of neurovascular surgery at the Pacific Neuroscience Institute. Beautiful location. I'm a little bit jealous hearing that. And is currently on the Tumor Executive Committee, both serving in the Bylaws Committee as well as the AANS Early Career Neurosurgeons Committee Chair. And I think obviously very well known for being an extremely talented surgeon, and one of the people who really has innovated a lot of the things in the fields in regards to modern neurosurgical approaches. So very glad to introduce him, and I think he's going to tell us a little bit more about what he does for research.
Thanks, Annalise. When I was looking through the slides of what everybody else has done, I think mine has the highest likelihood of not being around to do research on, as we do less and less surgery. But for now, brain surgery for tumors is still required in the majority of cases. And my research focus has sort of been developing since early residency of trying to find ways to make cranial surgery better. And I've gone through a lot of failed experiments and a lot of failed research projects, but I've gotten into this point of enhanced recovery after surgery. For everybody on this call probably knows about enhanced recovery after surgery. There are these multimodal longitudinal approaches that are all aimed to decrease the stress response related to surgery and the hospitalization. And it involves a lot of different members. Basically, anybody who sees or touches the patient during their surgical journey, either before, during, or after surgery, are involved in this multidisciplinary care pathway. So there's a lot of moving parts associated with it, which is why I'm drawn to it. I like systems, I like talking to people, and I like involving a lot of different people. So that's where this has come. A lot of the research has shown, even though it's only started about 20 years ago, these protocols in abdominal surgery, the data has been overwhelmingly positive, with significant improvements in length of stay, reduced costs, complication, and readmission rates. And it's pretty crazy they've shown since starting these programs in other surgical subspecialties, about $500 to $1,000 of savings per patient, which you can imagine the number of patients who are having surgery per year is pretty incredible. Some of the stuff has led us to this recent challenge. Providence, which is a 60 hospital system across Alaska all the way down to Texas, it's the third biggest not-for-profit hospital. My team and I won the Age-Friendly Innovation Challenge, and it was some money looking at developing and implementing a geriatric enhanced recovery program after surgery. Some special things about the geriatric population, as many of you all know, the Americans over the age of 65 represent the largest group undergoing surgery in the country. And we're looking at about 60 million people by the year 2020. And they take about 50 to 60% of all the surgical care that's done in the country. So we're running a pilot study looking at using everything from the pre, peri, and post-operative course aimed at decreasing that stress response. And some of the early calculations that we've seen that look in our hospital system alone, which performs about 75,000 surgeries per year, we're looking at, on top of significant decreases in length of stay, which our early data shows, say cost savings about $75 to $100 million a year. I'm really curious to see if that works out, and we'll see what happens with that money that's saved. That's going to be another interesting tidbit. I'll go to my personal things. So I'm married to my wonderful wife, Donia, who is a pharmacist, and our son, Sam, who's 2 years old, and he's most of the time wonderful. He got stuck out in the rain today and then came into my office and completely gunked it up right before I left. So not so wonderful, but overall, yes. I wish this was a false, but I did knowingly name my cat, who you see here, Sweetie Pie. I could say it was my wife. It wasn't, it was me. But I think you could see why, looking at that picture. So 2 facts in the fiction. I played tennis for UCLA during college. The only other job I ever considered other than medicine and neurosurgery was professional wrestling. And I am a huge Celine Dion fan. I think I shared too much here.
All right, Annalise, you have a few seconds to think about this as the audience is voting. And tell us which one is the fiction. I have a 33% for question 1, 2, and 3.
Yeah, this is a hard one. I would say that now that I know about the cat, I think you are a Celine Dion fan for sure. Like I think you sing to her in the shower. I can see that now. No, I'm joking. So I am going to guess, maybe it's played tennis for UCLA, and maybe you did want to be a professional wrestler. So I'm guessing the first one is false. Is that correct?
Yeah, you're right. Both of these are for the same reason. I never got big enough to be good enough to tennis to get on to UCLA, but I love the sport, and I'm going to try to push my kid to, I'm going to be one of those overbearing tennis dads. So we'll see if he can get onto that team. Had I been a foot taller, I probably wouldn't be sitting here during this conference and been in the ring for the WWE. That is I still think I probably prefer that over neurosurgery, but it's close.
Does the WWE have team doctors the way football does? Because you could be like a WWE team doctor. Yeah. I think you should. That would be great.
I would do that in a second.
Some of those Big Macs with Mike, I think you might be able to get there.
I believe that's it for my section.
We're good.
Thank you.
Well, thank you, everyone. Isabel, do you have any concluding thoughts?
Yes, I would like to thank you and Susan and everybody who agreed to participate tonight. This was incredibly nice and delightful, and I look forward to your closing remarks.
Well, I also wanted to echo Isabel's closing remarks and to thank Susan for co-chairing this, and to all of our panelists who not only were able to summarize their research in less than 5 minutes, which is hard for a neurosurgeon to do, but also open up and hopefully share a different side of not only our executive committee, but our tumor surgeons around the U.S. and the world. And I think all of us would be thrilled to have anybody who's interested in neurosurgery reach out to us, particularly in tumor neurosurgery. And we look forward to our next event. Our next event is July 18th. We'll also be doing it live and recorded for those who want to watch it afterwards. We encourage each and every one of you to attend it again. And thank you all for being here. Thank you for every one of, from Annalise, Wally, Isabel, and Susan, obviously, Ian, Kim, Mike, and Alfredo. This was a lovely event, and I look forward to the next one, July 18th. Thank you again, and let's end early then.
Thanks, everyone.